Hi, in this video we're going to be looking at how we can get started with testing in C#. So let's get started. Firstly, we're going to make a folder. So make directory Fallen World Studios. Okay, and then we're going to enter the folder, and in this folder we're going to create three things. Firstly, it is our solution file. So we're going to say .NET new SLN, which will effectively create our solution file. And then next we're going to create a project, and this project we're going to name calculation. So let's do it. We're going to say .NET new class lib -o, and you're going to call this project calculation, right? And our project has been created successfully. Now what we're going to do is take the calculation project that we just created and add it to the solution file. So we're going to say .NET solution add calculation. So our calculation project has been added to the solution. Next we're going to create our final project, which is called the test project, right? That is where we will be testing our code. So we're going to say .NET new NUnit -o test calculation. Yes, so press enter and our test project has been created successfully. Now we're going to do the same with our test calculation projects. We're going to have to add it to our solution file. So you're going to say .NET SLN add test calculation. Okay, so now the test calculation has also been added to the solution file. We have to reference these two projects. We have to reference the calculation project and the test calculation, so that our test calculation will know about our calculation project. So what we're going to do is we're going to say .NET add test calculation /test calculation .cs project .cs proj, and then we're going to say reference calculation .cs proj. Make sure that the spelling is correct. Okay, so yeah, we're adding a reference of calculation in our test calculation project, and then we press enter, and that's it. We have set up our project for testing. Now let us go to our Visual Studio Code. We're going to say code dot. Okay, if you didn't understand the previous steps, just go through them slowly. You can just restart the video and go through them slowly and you'll get them. Okay, so this is our files that we created. We first created the test solution. We first created the solution file, and this is the solution file that's been created here. It's called fallenworldstudios.sln. It's our solution file. And then we created our test calculation project and our calculation project. So to truly know that you've created the projects correctly, you need to run the tests. So we're going to say .NET test. Okay, as you can see now we have a test that is passing, but hold on, we did not write any tests, right? So what is happening here is that a test is automatically generated for you when you're creating the project for the first time. So to make sure that you've set up the project correctly, you must be able to get this output when you run .NET test. So now that we're done with that, let's actually go to the test calculation project. So we're going to go to the test calculation folder, and then we're going to go to this class called unittest1.cs, and we're going to get rid of this code right here, right? And then what we're going to do is we're going to rename the file to test add, right? And then we're going to go ahead and rename this class to test add. Okay, so as you can see here, we're getting an error it's saying the namespace test calculation already contains the definition for test ed. Okay, so this error usually happens, but I'm going to rename this file again. I don't know why that actually happens. It should be getting rid of this. If it doesn't get rid of this, then the only thing we can do is restart the Visual Studio Code. It might be the cache. Okay, can I say code? Okay, so now that is fixed, let us get started with testing. So what we're going to do is we're gonna go to our NUnit documentation, our test documentation. I'm gonna link it in the description. So this is it. So when you click the link in the description for NUnit documentation, you're gonna encounter this. So what we want to do here is go to writing tests, and under writing test, you're gonna go to attribute descriptions, and this is where you will know all the attribute descriptions. So what we're going to focus on right now is the test first, right? So under test, you can see here it says a simple test. This is what we're going to write first, a simple test. So let's go ahead and do it. So what we're going to be doing is an approach called test driven development, or TDD. It's called test driven development. Right. What happens here is that we assume that we've created the code when you actually haven't. We are writing test for code that doesn't exist yet, right? We're creating tests for code that we haven't created yet, right? So what we're going to do is we're going to say annotation test public void add, and we're gonna assume that there's a class that exists called calculator, and we're gonna create an instance of that class. Right, so as you can see, we're getting an error. That is because the class doesn't exist yet, but according to test-driven development, we are actually assuming that the class exists, right? So after that, we also gonna call a method that returns an int value. So you're going to say int return value equals to calculate. Inside the calculator class, we'll assume that a method called add exists, even though it doesn't exist. And we'll assume that it will take arguments of integer type, which means we're going to say just 2 and 2, right? So we'll assume that it takes two integers and adds them and returns a value, or rather an answer, right? And then we're going to create a variable of expected value, and that value will be 4, right? And then we're going to write our first assertion. We're going to say assert dot equal expected value is equal to the return value. So this statement right here checks if the expected value is equal to the return value, right? Which means if it is equal, that means that our method is correct. If it is not, that means that our method was implemented incorrectly. But remember that it doesn't exist and the class doesn't exist yet. So obviously now we're having an error here of calculator, and we need to get rid of this error by now writing the code. Remember, we started with assuming that the class calculator doesn't exist, and we wrote the test, right? But now we want to get rid of this error, so we have to start creating the class that doesn't exist. So we're gonna go to calculation, and under here we're gonna change this name class1 to calculator, right? And then we're gonna change this name as well, class1 to calculator. Okay, so we have created the class, right? So let's go and check if the error still exists. So as you can see, the error is still there, but now it's saying that could not found. What cannot be found? The class cannot be found, which means we are missing a declaration here. We need to say using calculation, right? Because the class calculator is in the module calculation. So now that you can see, the error is gone, but still we have the method inside the class that says it doesn't exist, right? That's because we haven't created a method called add inside the calculator class, right? So we need to go back to the calculator class again and then create this method also. We're going to say public, and remember the method returns an integer, and it must be called add, and it must take in two integers. I'm going to say x and int y, right? And it must return an integer. For now we'll return 0, right? And go back to the test again, and now you see that our code is compiling. There are no longer any errors, right? So now that's how we would usually go about test-driven development, right? We write tests for code that doesn't exist yet, but we're not done. We need to now create the test according to 3 steps. We're gonna call the first step the red step, right? This red step, it assumes this red steps says that the test must fail. Write the test to first fail. Your test must fail, right? So we're gonna say test must fail, right? So initially the test will fail because here we're saying the expected value is 4, and if we're passing in the parameters 2 and 2, right, which is correct, but here the method returns 0. So we are intentionally writing the test such that we are intentionally implementing the function such that the test will fail. We're doing this on purpose, right? So we're going to say .NET test as you can see, right, expected 4, but our method returned a 0, so the test has failed, right? This is good. Now what we need to do is implement the second step, right? This is the first step. The red step says the test must fail. The second step will say green. This is called the green step, and it says that test must pass but with minimal code possible, right? So now you must make the test pass but with the minimal code possible, and the only way we can make this test pass with minimal code possible is if this method right here returns this expected value 4, right? So we're just gonna go here and change this 0 to a 4, right? And then run the test again. As you can see, now we have a test that is passing. We have effectively executed the green step. Now the last step. The last step is called refactor. Now what we're trying to do is refactor the code. Refactor the code, the test code, such the code, sorry. Refactor the code such that all tests pass, right? So what we are going to do here now, we're going to refactor the code such that any test under this that tests this method will pass. For instance, if we were to add another test here, we're going to say remember test public void add 1, right? And we're gonna say calculator calculate equals to new calculator, and then int return value equals to calculator dot add. Now instead of adding 2 and 2, let's say we're adding 3 and 2, right? And then obviously we then expect the value to be 5, right? Because 3 plus 2 is 5, right? And then we do the assertion assert.equal return value, sorry, expected value and return value. So obviously we know now that this test will fail, because remember in our method here we are returning a 4 because we were trying to suit the conditions of this first test. So only one test will pass. Only one test will pass, and this one will fail. So let's run the code again. Okay, so as you can see, the first we have a single test that is passing and a single test that is failing. And this test is saying that we expected 5, but the method returned the 4, right? So now this is where the refactor step comes in. You are now cleaning up your code such that it passes all the tests, right? So you're gonna say x plus x, right? You are now returning x plus y, sorry. You're returning x plus y. And then you're now going to run the code again. As you can see, now we have 2 tests that are passing, right? All the tests are passing, right? And if we were to add more tests, our method would still hold. For instance, if we were to just copy this and paste it and just say this is test 2, and then change these values to -3 and 2, and if we add -3 plus 2, we get -1, right? So if we run the code again, we should have all the tests pass. As you can see, 3 tests are passing now. So you have effectively implemented the test-driven development approach. Remember, you first assume that the code exists, even though it doesn't exist, because you are developing by writing tests. So you write tests for code that doesn't exist yet, and then after you do that, you make the code compile by actually creating the code, and then you first make your test fail, the red step, and then you make the test pass, the green step, by writing the minimal code possible, and then you refactor your code for all your tests to pass. Okay, so that was nice and all, but now let's look at another attribute. Remember, in the documentation we have a lot of attributes. We're not going to go through all the attributes in this video, but we're going to look at test case. Before we look at a test case attribute, let's first go through this part of this part of the test attribute, right, where the expected result is written inside the attribute, which is interesting really, because it will really clean up our code. Let's say now we are using that attribute, but now instead of writing the expected result here, we got rid of this expected value, and you just said that the expected result equals to 4, right? So now we no longer need this assertion. We no longer need this, right? Because we will now compare our function add with this result right here, the expected result, and it must exactly be like this. You must write it exactly like this: expected result equals to the number you're expecting. And then this method must now change to return an integer, right? And then you must obviously provide a return type here, which means we will return whatever is being returned by the calculator method. We're just going to say return calculator.add. So whatever the calculator.add method returns, it will be compared with this expected result at the top, right? So we can do the same with our add1 test, right? Remember, here we're expecting 5, so we're going to get rid of this. We're going to go here, put into parentheses expected result equals to 5, change this method to return an integer now, and then clear this assertion because we don't need it. And then instead of assigning a value here, we can just say return calculator.add, right? Same with this method also. We're going to get rid of all this, put parentheses here, expected result equals to -1, and then return, right? Oh, we also need to change this void into integer, into int, right? And then you can see now that our test is more cleaner, right? This is more nicer and clean. Now let's run the tests. .NET test. As you can see that our tests are still passing, which is great. So now we're going to take this a step further, but we need to do that with another example. Let's create a new file here. We're going to call this file test subtract.cs, right? And we're going to add our modules here. We're going to say using NUnit.framework, right, for our NUnit test, and then using calculations, remember, right? And then we're going to say public class test subtract, right? Okay, so we're going to write our first test for subtractions, right? We're going to say public void subtract, subtract int. Okay, let's just keep it simple for now. And then what we're gonna do, remember what we did previously, TDD approach, right? Test driven development, TDD approach, test driven development, right? Assume that a class exists, for which now it actually exists. Calculator equals new calculator, right? And then in that class you must assume that a method exists and it's called subtract, right? And it takes in two values, let's say 3 minus 1. So it takes in two integer values, right, and returns a value, right? And then you make an assertion, set.equal. Remember, we need to write an expected value, but this time we will just skip that and say 3 minus 1 should be 2, right? And then compare this to the return value, right? Also, we need an attribute here, otherwise this is not a test, right? So we're gonna just say test for now. Now realize now that this code has an error, right? This error, subtract. So what is going on here? Oh, firstly, we have another major error here in this file. Why do we have this error? Okay, yeah, it's because of this error, sorry. Okay, we have this error here, calculate.subtract, which is giving us an error because subtract does not exist, right? We need to create it because remember, we are using the test-driven development approach. So we assume that the subtract method exists when in fact it doesn't exist. So let's go and create this method so that our code compiles. I'm gonna say int x, int y, right? And this method will return 0 for now, right? So as you can see now, the error is gone, right? The error is gone, it is compiling. Now what we want to do though, we want to use a different attribute other than test, right? So we want to do a different attribute other than test. Let us go back to the documentation. So we said that we want to use our test case attribute. We're going to click on test case. So we moved from test to test case. So test case, what does it do? It serves the dual purpose of making a method with parameters as a test method, right? The dual purpose of marking a method with parameters as a test method. So it takes in parameters and provides inline data to be used when invoking that method. here is an example of a test being run 3 times with 3 different sets of data. So the first test is test case, and then provides the input 12, 3, and 4, right? And then it provides the parameters int n, int d, int q, right? So what you must realize here is that these parameters here correspond with these values here. For 12, 12 is n. For 3, 3 is d. For 4, 4 is q, right? And q stands for the expected result. And they just say assert dot that, and then they just compare this, which is nice, right? And remember, the method must be void. So let's try this. Let's actually try this, but with our own subtract method. We're gonna say test case, and then we're gonna pass in. Remember that these inputs right here that we're passing in are actually the inputs of the test case, right? So we're gonna remove these here and actually paste them here, 3, 1, and then the expected result is this 2 right here, right? So we're gonna remove this 2 and actually put it here. But then we have to make sure we pass in the parameters here in the subtract method. We're gonna say int x, int y, int r for results, right? And now in this method we're going to do what? We're going to pass in the x and the y, which will stand for the 3 and the 1. And here we're going to replace this value that was here with r, which will be the result, right? So what did we do here? Remember that instead of putting our inputs here inside the method, we're actually putting our inputs here, 3 and 1, and then we pass them as x and y into this test method right here, and then we effectively pass them here on this method that we're calling from calculator, right? And then for the expected value, it is r. This value here, 2, will be the r, which is our expected value, and we pass it here. Okay, so that was a mouthful. Let's run our test and see. Oh, before we run our test, remember that we have 3 methods, right? The first one is the red step. So we are currently on the red step, which means tests must fail, right? Our test must fail because right now we're returning 0 here. Our test subtract must fail. So let's run our test. .NET test. As you can see, the result that was expected was 2. So you can see that the 2 was actually passed. This 2 right here, if we got this down a bit, this expected value here, as you can see that it's passed in as an expected value. But what was returned, it was 0 because we are on the red step. But our other 3 tests are passing from the test ed. They are passing. The test that is failing is the test that we're currently writing, right? The subtract test. And it's right now returning 0 because we are on the red step. Now let's do the green step that is following. So let's close this for now, and we're gonna say we are on the green step, which means that test must pass with minimal code possible, right? Which means since we're expecting 2 here, we can just say this must return 2, right? And when we say .NET, when you say .NET and we run, so here you go. We have all our tests passing now, right? But remember that we must not leave code in our green step. We must refactor our code to the refactor step, right? So what we're gonna do is we're gonna say now we must refactor tests must pass, all tests must pass, all tests must pass with our refactored code, right? So what we're gonna do is we're going to write another test, right? You're just gonna copy paste this, and then we're gonna call this subtract 1 so that we don't get that error, and then we're gonna change the values. Let's say we're gonna say 0 minus 1, which will give us minus 1, right? And then we need to refactor the code now, because we are on the refactor step that says all tests must pass with our refactored code. So we need to change this now to say x minus y, right? So it will return x minus y. So let's run the code. Delete this. .NET tests. Okay, so all our tests are passing. 5 tests are passing. Alright, now let us go back to our documentation again. Let's just review the test case. So you can see now they say that we can even limit the number of arguments we can write here by writing expected results, by explicitly telling the attribute that this is the expected result, and then passing in a return value here. So let's try writing our code in that manner now. So what we're going to do is we're going to say here we must explicitly say that this is the expected result, right? Same with here, this is the expected result, right? And now we must change this void to int. We must change this void to int, and then we can get rid of this assertion. We can get rid of this assertion also. We can also get rid of this int value and instead just return this. And here also we can just get rid of this return value and instead return. Okay, just like that. This effectively cleans up our code. As you can see, we just explicitly stated that this is the expected result, and so we changed this to return an int and then returned whatever calculator method was returning, and the same with this code below. Now let's run our tests again to make sure that we didn't break anything. Okay, so we see we did break something. Let's see. So what is it saying? Method requires 3 arguments. Oh, okay. So what is happening here is that in the documentation they specifically said that once you add expected results explicitly, you don't have to include a dead parameter. So remember that before we had a dead parameter right here, but now this was removed. So we're gonna go back to our code and correct this. So we're gonna clean this up and say we remove the R because we don't need it now, because we are explicitly saying that the R, or the expected result, is equal to 2. So we don't need this anymore, which is nice because it makes our code shorter. We don't need this here also, right? Now let's rerun the test. Nice. Okay, so all our tests are passing, and the important thing to take away here is this. This is the important bit here. Remember, test-driven development is amazing. In a large project, it can really save your time because it makes you confident in the code that you write. You know that your code will contain less bugs if you apply test-driven development, and it will make you. It's actually nice to write it, to see that green when your test is passed. It's amazing. Trust me. At first, it might sound weird to write tests for code that you haven't written yet, but once you get used to it, you'll get addicted to it. Trust me. Okay, so we are done for this video, but really, if you really wanna mess around these attributes right here, just go through the documentation. It's very clear. Just go through each and every attribute right here, read it, find out what you can do. There's so much you can do here. We have order, one-time teardown, property, random, all these attributes. Just go through them, practice, make your own test, and just find out what they do, especially the setup and the teardown method. Just look at the setup and the teardown method first when you're doing this. Anyways, thank you. I hope you enjoyed the video, and don't forget to like and subscribe if you find the video helpful.